Hope you guys had a good Veterans Day yesterday. If there's any vets out there in the audience, thank you for your service. Or if any of you have family that were vets, my father was a Marine. Anyway, didn't really know him, but oh. Let me see. Anybody have any questions from homework or anything? All right. Okay. All right. If there's no questions, we're going to jump back into new stuff. Jump back into new stuff. Maybe I'll remind you guys what we did last time. Well, a little bit. Let's see. So the two main things we learned on Tuesday. Does anyone remember one of the things we learned on Tuesday?
Pythagorean Theorem?
Yeah, good old Pythagoras, the old Greek jackass. He stole all his followers' work and made it his own. But oh well, math history is like that. There's poisonings, there's duels, there's crazy people, there's gambling, there's infidelity. It's insane. People would probably not watch the movie of the history of math, but it is kind of freaky.
It's like Game of Thrones.
It totally is. It totally is. Game of nerds? I don't know. It would be something else. It would be except season 8 of the Game of Nerds was better than the Game of Thrones. I'm sorry. Let me see. And the second thing we learned, so first thing we talked about was a squared plus b squared equals c squared. Good old Pythagorean theorem. And then the second thing that comes right off of that was the distance formula. All right, so there's Pythagorean theorem. Oops, you can't see this, can you? Dadgummit. There's a good old Pythagorean theorem. It only works for right triangles. And to be honest, I don't know if you guys are curious about this, but there's a slightly bigger, it's got one more term in it if your triangle isn't a right triangle. There's actually something that works. It's got more shit in it, but it works even if it's not a right triangle. The formula becomes a little bit more gross. There's one more piece to it, just in case you were curious. But this nice little equation here only works if it's a right triangle. Okay, maybe. And then we used that Pythagorean theorem to create, where are you? The distance formula. There it is. Good old distance. And it feels a little bit like we're going to do slope. When we're doing distance formula, it feels sort of like we're going to do slope, but then we don't. Turn a corner. All right. So that's what we talked about last time. There's really just those two things. All right. Whoa. So if there's no questions, we're going to get right into this craziness. Does anyone have any questions? Doobie-dooby, 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 doobie-doo. No. Okay. Okay. All right. Well, let's get right into it. I love it. All right. Here we go. I want to show you a couple of websites. Here we go. Let's start with this one. All right. Where'd you guys go? There you are. Move over there. So I know well, I think most of us know the election is over. Some people out there don't seem to think it is, but here's something from right before the election from the BBC. If you look at this very quickly, can you ascertain what's going on here? Maybe not down over here, but up here you can tell what's going on here. I mean, this is obviously the results of a poll done on November 2nd. They tell you what the poll was, and they tell you the results, right? You guys with me? A little bit, little tiny bit, little tiny itty bitty bit? Okay, stay with me. Now, what the shit are these numbers? Holy shit. let me tell you this right now. LV. Does anyone know what LV might stand for? It's not little vampires, right? It's not loquacious violinists. When you're talking about an election, who do you want to talk to? Who do you want to ask their opinion about the election? Who do you want to talk to? People that are probably going to what?
Vote.
Before the, huh? Say again, sorry. Oh, I see. Okay, Riley's starting to stir up some trouble here. LV actually stands for likely voters, right? Likely. Illegal voters are captured by the same process we use every damn election, right? We verify and count the legal votes. Oh, you're fine, Riley. I pretty much understood that, but you got to be careful. Yeah. But likely voters, right? Likely voters. So this is the number of likely voters they talk to. And look at this bad boy. Now, this is probably a several put together, to be honest. Most of them hover around 900 to 1,200, maybe even 1,500. All right, is everybody with me so far? Everybody with me? This is nothing major. So that's what that last one means. When they say sample, this is their sample size, and LV means likely voters. Let me turn off my heater. Or else I'll just keep yelling at you guys. Okay. So again, these are the results. And if you look down here, there are some that went the other way, right? Bam, 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 bam. This number is what's most interesting right here. It tells you up here what MOE is. Well, up here, it also tells you LV is likely voters. So all I had to do was read a little bit earlier. But MOE stands for margin of error. That's the plus or minus whatever percent. So I want to show you something a little more interesting here. So you can see one thing I want you to realize. What is the connection between the margin of error and the sample size? Let me kind of scroll down a little bit. Do you guys, as you scroll down, can you see the relationship? That's all right. Okay. Somebody has this head out. Can anybody see the relationship between the margin of error and the sample size? It's not a perfect relationship, but does anyone see like a general relationship between how these go and how these go?
Margin of
Look
error is smaller if the sample size is bigger, I think.
Yes. And think about, come on, stay with me. The bigger the sample I take, if I take a large sample, will I be more certain about what I see compared to a small sample? You guys know this already. You haven't taken statistics, but you know, is it better to take a big sample?
Yes.
Why? Because then you're more sure. So of course it makes sense that generally the margin of error goes down as the sample size goes up, right? It's not a lockstep thing. It's not a linear relationship, but it is a general idea. You guys with me? And it matches with what we already know, right? I don't have to teach you statistics for you to go, oh, big sample better, right? We know that. So let me show you this. I like this other website. Get out of there. Rawr. Can you guys see the other website? Looks like a global warming kind of thing. Can anyone tell me? Can you guys see something else that's got red and blue, like shaded boxes? Are you guys seeing that now? Anybody?
Yeah, I can see it.
Thank you. All right. So what this is obviously the bluer, the more it's leaning towards Biden, and the redder, the more it's leaning toward Trump. But watch this. I want you to really understand what this is doing. Does anyone know the website 538?
Yeah, that's what I was keeping track of.
Yeah, dude, 538. That's a big one. Nate Silver. And where's the number 538 come from? Does anyone know? Does anyone know how many electoral votes it takes to win the presidency?
538.
No.
Nate,
Good catch.
270, 538 total.
There you go. It takes 270.
270, yeah.
And there's 538 total. So if you got 269 to 269, that's a tie. To be really honest, I can't remember if that's ever happened. So all you need is 270 because that would leave only 268 for the other person, and you win. Is everybody with? So that's where the word 538 comes from. That's where the name of the website. So look at this. Look at this. This is what they saw from their samples they took for these states. But with the 3-point national error, plus or minus 3%, it could either be up higher for Joe Biden or lower for Joe Biden, depending on if it's plus or minus. Are you guys semi with me? So what they're saying is in New Hampshire, Joe Biden was up 10.6%, but there was a 3-point margin of error, meaning it could have been 3 higher or 3 lower. So for example, something like Florida, where that they were ahead of time, they said Joe was going to win Florida. But do you see how they thought he was up 2.5? So there was a chance that he was actually down 0.7. And it ended up being even more than that, right? Are you guys semi with me at all? I like this website because it shows you this is what they predicted. But this is adding the 3 possible, and then this one is subtracting the 3 because it's plus or minus 3. It's got a range of 6. They could have been off by that much. What we're going to do today is we're going to figure out how to calculate that error, given some information. We're going to actually be able to figure out that, like this, get over there, this error here, 3.3%, 2.3%, and so forth. You guys with me? A little tiny bit? Not at all?
Yes, I follow.
Okay, thank you. All right. Now, unfortunately for me, but I think you guys might like this better, is I'm not going to go through the math behind the formula. If you take statistics, which I think most of you guys are planning on taking statistics, you'll actually go through with your teacher where this formula comes from. I'm just going to give it to you so you can work with it mathematically, but you're getting a little bit of a preview of this formula, right? So let me stop sharing so I can reboot myself. Actually, maybe I'll do this up on the, yeah, why not? I can get off my ass. That'll be new. Do this up on the board. Oh, let me check one thing. Depending on the book you use, they use different notation. I'm gonna use the same notation this book does. Scheisse. Yeah, okay, good. They use the right notation. Hold on. Get up there. All right, so now watch. Let's say we talk to, let's see. Let's say we talk to 1,200 laughing Venezuelans. I mean, likely voters, right? 1,200 likely voters. And let's say that, what do you got, Jeff? I don't know. Let's do, so let's do 580 of them say they'll vote for Trump. I can't capitalize his name, I'm sorry. And this is right before the election, right? So we talked to 1,200 likely voters, and somehow 580 of them said they're going to vote for this person. Okay. Can somebody tell me what percentage that is? What's the percentage of the people we talked to that said they're going to vote for him?
48.3%.
How'd you get that?
A calculator.
Calculator, but what'd you put in the calculator? You didn't just go calculator, do this.
I divided 580 by 1,200.
There you go, okay. So that's the work, right? And that, of course, now, see how I put an equal sign there? I'm going to put the symbol here in a minute. So everybody kind of double check this. If you do this, what am I doing? Just put in the old calculator. What do you guys get? Did you get the same thing that Vu did? See, divided by 3 times divided by 3 times 5. Screw it. Look at me. I'm trying to do it in my head. Are you guys? I'm going to say that that's right. So what'd you get again? I'm sorry.
48.3.
Okay. Cool. Is everybody else getting that same thing? Are you guys good? So this is something. Oh boy, I hope my Wi-Fi is okay. This is something I really hope you come away from this class with, is the ability to work with percentages, right? We've been working with percentages off and on, and they're crazy important, right? Okay. The symbol we use for this is not just a P for percent. We put a little party hat on them. P with the party hat. The little party hat. All right, stay with me, stay with me. What are we working with here? Are we working with a population or a sample? What do you guys think? Are we working with the population or a
Are
sample?
you always working with a sample of a population?
Not always, no. But in this case, most of the time, yes. Sometimes we actually work with the whole population, believe it or not.
Oh.
But in this case, we're definitely working with a sample.
My thingies went out. Can you say what you just said again about the party hat?
The little party hat means that this is a sample percentage. If it was a percentage for a whole population, I would give it the letter P. Population percentage. Holy crap and a half. So a little hat on it means it's only a sample percentage. He can take his hat off if he's a big old population percentage. How are we doing out there? So you'll notice if you do take statistics, we very often have one symbol for a population something, and we have a different symbol for a sample something, which kind of makes sense. It's important to know which one I'm using. All right. Now, one thing the book does, which I think is really silly, and some statistics books do the same thing. What percentage did not vote, did not say they were going to vote for Trump? What percentage said they, that I talked to, are not going to vote for Trump?
51.7.
Yeah, so it would be 1 minus 0.483, right? Because that's really 0.483, right? You made it into a percentage. Is everybody with me? If the probability is going to rain today is 10%, the probability is not going to rain is 90%, right? They have to add up to be 100%. So you would get 0.517 or 51.7%. The letter we use for this percentage is Q, and we give it a little hat. So P hat is a sample percentage of that said yes, and Q hat would be the opposite of that. So we haven't really done much. We've talked about how to get a percentage before. That's all we did here. 580 out of 1200. Ooh, no big deal. The new thing is this is specifically a sample percentage. That's the symbol for it. Q hat is the symbol for the other part, right? So these people said this, Q hat is the other people. So of course they always have to add up to be 100%. You guys with me? Now let me ask you this little side note, this non-mathematical question. Does that mean that 51.7% we're going to vote for Biden?
No,
No, exactly. You guys know how many
because you
candidates?
got that error margin, right?
No, even more than that. There's not just 2 candidates. How many total candidates were there?
Oh,
You guys know this?
Oh God, there were so many running
Yeah.
that I just couldn't care about.
Thank you.
well,
The last I checked, there were 1,200 something, I think, or 60. I can't even remember. It's in the thousands. Do you understand? Nobody knows this shit. And some of those people have names like Holy Crappity Doo Head and stuff. I mean, these people are. There you go. Yeah, Kanye was in there. Joe Jorgensen was the Libertarian candidate, and then there was a Green candidate, and then there was a Whig Party candidate, and then there's a Communist Party candidate, and then there's a Socialist Party candidate, and then there's these crazy ass parties out there. You have no idea, right? And maybe I should look it up, but there's an official list of all the presidential candidates, and I'm pretty sure it was at least 1,200 total candidates. Are you guys with me? Sort of like, do you guys remember the governor election in California? There was actually 100 some odd candidates. One of them was Gary Coleman at the time. I don't know if you guys remember this.
Yeah, I do remember that. That was awesome.
So normally people know maybe at most 3, and normally most people only know 2, but there's always many more. Okay. All right, sorry. That was all a side note. I'm really sorry. So this just means that percentage did not say Trump. Some of them said Biden. Some of them said Joe Jorgensen. Some of them said from the We Don't Give a Crap party. I mean, anyway, sorry. It'll blow your mind to know how many political parties there are and how many candidates they put forward. Holy shit. Okay. What's that got to do with anything, Jeff? I don't know. So you ready? Here comes the formula for the error. So what would the error be for my sample? I wouldn't just say this. I'd have to say plus or minus some percent. So here's how you get the margin of error. It's the square root of p hat q hat divided by n. If you take statistics, you'll actually see where that formula comes from. And I left one piece out. Of course I did. This is all right. There's one extra little thing in front of this. And for us, this is always going to be a 2 right here. 2 times this. This number can change in certain situations once you get into statistics. But for us here in this class, it'll always be 2. Now, this next piece is not crazy important, but I want to at least lay this down. This is assuming you say 95% confidence. So we would say something like we're 95% confident that we're off by this much. So there's a 5% chance we're off by more. Good Lord, that gets complicated. The only way to be 100% confident is to say it's anywhere from 0 to 100%. And that's not very useful. All right. I don't know if you guys are with me at all. So this number would change if I want to be more or less confident. Again, this is not very important at the moment. This will become a lot more important once you get into statistics if you're going to take it. This formula is how to get the error that you normally see. So let's try it on this situation. Let me take this weird shit away. Let's try it with this. What's this error going to look like? It's going to be 2 times the square root of 0.483. You always use the decimal because that's the real number. We made up percentages. 0.483 times 0.517, right? P hat right? P hat, Q hat, divided by N, 1200. All right, let's see if we can all put that in the old calculator. I think Kanye conceded, right? Let me see. How many votes did he get? That almost makes me more worried than, well, maybe not. The votes that Trump got. All right, let me see. All right, let me do this in the old calculator here. So if you put 2 times the square root. Now, if you have a graphing calculator, you might have the kind that the square root symbol has a parenthesis after it. And then you want to be real careful. You don't want to close that parenthesis until you're done. I'll do it the other way too. Hold on. So you should be getting about 2.88, well, almost 3% here, right? So what's the other way this could look like? This could look like, don't worry about this. This could look like this instead. You might have a calculator where the square root symbol just grows across the whole thing. That's nice because then you can really see that it's all in there. So let me know if you have any trouble with that. Everybody should be getting like 2.9%, right? 0.029 roughly if we round. So I would report, or 3% if I, how much I want to round is up to me. That is where that comes from. If any of you have ever paid attention to when they talk about percentage of people that are going to vote for something, there's almost always that plus or minus number. They don't just pick it and go, I don't know, maybe we're wrong. Let's say plus or minus 4. No, it comes from this calculation. You guys doing okay out there? So let's try another situation. You guys do this problem. Put the formula up here in the corner. That's me in the corner. Look at my hat. That's the error. Let's say you talk to 1,857 people, and 403 say Gary Coleman should have been our governor. This is a while back, obviously. Gary Coleman should have won. Figure out what P hat is, figure out what Q hat is, and then figure out what the error is. Go. I think I looked this up before. Let me see. Every single day. No, no, you will work. There we go. There we go. Yeah, it was 1,200. All right. I'll show you this. I'll show you this list. It's crazy. This list is not as good as it could be. Oh, I got somebody out there with an answer. Man, all right, fine. All right, guys, help me out here. What'd you get for p hat? Oh, I should have done this too.
Is that the actual name, P hat?
Yes, sorry, yeah, that's the p hat. That's the one you don't want to wear by accident, right? You're out in the boat, you don't have a jug, you got to use a p hat. P hat. What do you guys get? Anybody?
21.7%.
Gas. 21.7%. I'll put over here 0.217. So what's Q hat going to be? I don't even have to do this work. I can just do 1 minus that. Did I ever show you this trick? How to do this real quick? What makes that 9? 7. What makes that 9? 8. What makes the last one 10? 3. All right. Maybe is everybody good out there? You guys all right? So then the error is going to be twice the square root of 0.217 times 0.783 divided by 1850, become a 57. Whoa. Oh yeah, Jeff. That was smart. My job would be so much easier if I knew how to use my calculator. Yeah, so somebody already sent me the right answer. Did anybody else get their answer?
Yeah. Like 0.9, 1.9.
Yeah, 0.019, so 1.9%. So what we would say in an article is that it looks like 21.7% say that he should have won, give or take 1.9%. This would be at the bottom of the article. This would be you would see this at the bottom, plus or minus 1.9%. So our percentage could be off by this much. Either it's higher by this or it's actually lower by this. And what do I really mean by that? I mean the actual percentage of everybody who say this. So this is just a sample. That's why the answer I get from the sample isn't necessarily the right answer for the population. So this is how far off I think I am from the population percentage. So now you see why polls give us numbers that aren't necessarily right. They actually are, but people just forget to factor in this. It could be off by so much. Maybe. Not really. What's the only piece of what I've said that you really have to worry about? The math piece. Can you calculate these? Can you put them in the formula? Can you use your calculator correctly? Right? All right, let's take a look at some problems in the book. You're really up in my business. All right. Oh, where am I? Let's see. Okay. Oh, let me show you this real quick. What sucks about this website is it doesn't tell you, see where it says American Independent Party? Okay, that's one. But where you see independent or nonpartisan, the actual party name is sometimes very entertaining, right? But I mean, look at this. These are all the people who filed for the election, 1,212. I'm trying to see if there's any, let's see if there's any really interesting names. Anyway, I mean, just look at this. Holy shit. I like Herbert, Ezekiel, Zeke, Smith, but sometimes there are excessively strange names, but I'm not going to do this for too long. Blah, 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 blah. Okay, enough. So let me stop sharing that. Let me share this instead. Where are you? Where are you? There you are. Okay. All right, so here's this. I have no idea. Where are they talking about Bigfoot? Oh, the percentage of Americans think that Bigfoot exists. Hey, it might exist. Why not? I don't believe it exists because I haven't seen enough evidence for it, but could it exist? Of course. I've seen Harry and the Hendersons. All right, blah, blah, blah. I don't want to get too much into this crap. Let's see. Let's go to the group work. Here we go. So here's where they're talking about the confidence that I was talking about earlier. Confidence is measured as a percentage. So the two, stay with me now, stay with me. And again, you could do this whole section without understanding what I'm saying right now. The two in the equation that we use comes from 95% confidence. If I wanted to be 99% confident, I wouldn't use 2, I would use 2.6. It would go up. If I wanted to be less confident, that 2 would go down, 1.65, 1.28. Do you have to really get that? No. I just want to give you a bigger picture. All right, maybe. It doesn't affect what you're going to do in this section, but it's just the reality of the situation. Blah, blah, blah. Let's see what this says. Associated Press poll indicated that 63% of teachers below college level feel like the amount of homework students get is not excessive. Yeah. The poll had a margin of error of plus or minus 3.5%. So what does that mean? What does that mean by itself? Anybody? There's a few different ways you can answer that.
It could be higher or lower than 63% by.
Yeah, so you could answer by saying it could be anywhere up to add 3.5, right? Up to 66.5, or anywhere down to 59.5. Is everybody with me? Anybody not with me is a better way to ask that. Right? That's that website I showed you where they actually applied this and said, oh, in reality, it could be anywhere from this to this. And how certain are we about that? We're 95% confident about that. And again, statistics gets a bad rap because people say it doesn't tell me the exact answer, but that's freaking real life. That's what I love about statistics. It's the most honest math. It says, it looks like this, but I could be wrong. And everybody gets angry at it, but it's like, what the hell do you want from me? I describe real life. And are we ever 100% certain in real life? Ever? These last 4 years have definitely shown us no. Especially this last freaking year. Are you kidding me? 2020. All right. Maybe? No? All right. All right, let's see. So here's their formula now. I want to point something out. They don't talk about Q hat. That's the thing I didn't like. Do you see here in here they got 1 minus P hat? That is what Q hat is, right? I just want you to know. So when you go into statistics and you start to talk about P's and Q's, you know what the hell Q is. Okay, maybe. All right. Oh my gosh. Really? A whole new, don't you dare close your eyes. All right. You guys remember that whole thing? Don't you clear? I was like, that's how romantic. Don't you dare close your eyes. All right, sorry. So here, try this problem real quick. An organization called Public Policy Polling released the results of a poll with 532 responses. 181 supported one particular candidate for president way back in 2016. Oh shit, we're going even further, aren't we? Among those folks, 41% were in favor of bombing Agrabah. Oh, holy shit. Oh, this is true. Dude, I remember this. All right. This is kind of crazy. All right, this is a little bit evil, this problem, and I want to tell you why. All right, guys, stay with me now, stay with me. This problem is specifically evil. Which number that they give me up here do I not care about? And I don't mean the date. Which number do they give me that I don't care about? This is a little bit evil. I don't know. This might be extra evil. I don't care about the 532 because what's the 41% coming from? 41% of who?
181.
Yes. All right. So this problem, you don't do 181 divided by 532. This is a little bit evil. I already know p hat. P hat is 41%. So this problem is a little bit evil. And n is 181. So when they sent out the poll, they got 532 responses. Then they focused on 181 people who supported, I think you can assume, you know who they supported. And amongst those people, 41% were in favor of bombing Agrabah. And this is a true poll. I remember this. So let's see. Let's do this together. What do we know then from this problem? This problem's a little bit evil while also being really nice because it's already done the work for me if I notice it. That is p hat. Me write it as a decimal. That is n. This number doesn't matter. Can somebody tell me what q hat is? If p hat is 41%, q hat has to be how much?
0.59.
Yeah, 59%. It's got to be the rest, right? P and Q, whatever clothes they're wearing, have to add to be 1 because they're always going to be opposites of each other. And now I've got all the information I need. I can plug it in my formula. Twice the square root of 0.41 times 0.59 divided by 181. So we can see what the margin of error was. While you guys do that, I'm going to look that poll up. Oh, so yeah, okay. This is an actual poll, but they kind of got the numbers wrong in this problem. Oh, well. So what do you guys get for this?
7.3%.
Yeah, let me see. Let me see what I get. Can I get the same thing? Yay, Jeff. So this is kind of a big, that's a relatively big margin of error, right? We normally see like 2, 3, 4. Why is this margin of error so big? Does anyone see why? Yeah, sample is freaking small as shit, right? Now,
Excuse me, Professor, could
yes.
you please explain a little more about how did you get the 59?
Okay. Are you cool with the 41?
Yes.
This is the opposite of this. So if there's a 41% chance of this happening, what's the chance that it doesn't happen the rest? So all we did was we did 100 minus 41%, right?
Got it.
I could just draw, and that's 59%, which we write as a decimal. Yeah, I like it. So it's just like, what? I felt
Got
like I
it.
was,
Thank you, Professor.
you're welcome. I felt like I was going through a drive-through there. All right. So I'm really sorry. That problem was a little evil. They gave you extraneous information that was evil. But, oh well, we're used to this book doing that every now and again. Yeah, okay. Let me show you this real quick. I just want to show you this. Let me stop sharing this. So the book did get it a little wrong. This is a real poll. 30% is the real percentage. I don't know why they made it 41% in there. So I just want to be transparent. It's still kind of scary. I mean, there's the 532 number, but then I don't know why they changed it. Oh, well, too bad. But that's a real poll. There were real people who wanted to bomb the city that Aladdin lived in the fictional story. All right. There's also a poll where I think it was 4 or 7% of people think that chocolate milk comes from brown cows. Look that one up. Yeah, yeah. Then
That's true.
things make more sense about the number of people that voted for certain people. Yes? Okay, all right. Let's see. Is there anything else here I want to do? Oh shit, that's the wrong thing. Sorry. I've offended somebody. Somebody just left. All right. Yeah. What I used to say is, because I sometimes use colorful language, and somebody got offended at it, and I said, if I ever offend you, then just wait a minute. I'll probably do it again. And that's why I love teaching college. Too damn bad. All right. Let me see. Let's see, what else do we want to do here? Wait, screw that. Let's go. Let's continue. Let's go past this problem. Here we go. No. Get out of here. No. This is all about Agrabah. Let's do something else. Here we go. All right, let's try one more example. Number 9. Yeah, suppose that you begin surveying students. After 70 surveys, you find that 32% of them think that race relations are a serious problem. Do I have to calculate p-hat? Do I have to divide something to figure out what p-hat is?
No.
So be really careful. You're not always going to have to divide numbers. They sometimes are just going to give it to you. So, you say, thank you, problem. So go ahead and do this problem. I'll put the formula up here again. Oh, I got Mr. O20 is back. Mr. O20, bam. All right, let's see. N is 70. That's a very small sample, right? But still a valid sample. It's just small. It's probably gonna end up with a large error. So when I put this all in here, let's see, I get 0.32 times 0.68 divided by 70. Let me see if I could do this in my head. 2, 3. Why are you trying to do this in your head? I don't know, man. 1/4, 280. Oh, that's interesting. Oh, let's see. 280. I don't know. What's the square root of 280? 12. 1.4. Oh, God, Jeff, why are you doing this to yourself? Oh, I gotta stop. It's like 16 divided by 1.4.
It's 0.1115.
And all right, I'll accept it. 1115.
Yes.
Thank you, Nikki. You're sitting there watching me, like, let me save this. Crazy. Math teacher from himself. So if they don't say we can round, well, let me get you guys used to this right now. What was it, 1115? So you should round these to 3 places. Let's start doing that. Well, unless they say otherwise. If they say something about it. So this will be a plus or minus 11.2%. That's relatively big. And it's because of the fact that we have a small sample. Okay. Oh, okay. All right. Now we're getting interesting. All right, you guys ready? Buckle up, Buttercup. Here we go. This kind of sucks that I should have pulled this up higher. Oh, well. Dadgummit, Jeff. Let me see if I could do it right now. That's not too bad, right? Okay. Get ready. Here we go. Get ready. Oh, shit. Now, look at what they're saying. This is kind of nifty. Right? That sucks. Do you guys agree with me that that sucks? If you said to somebody, yeah, I think it's about 60%, give or take 11%. It's like, I don't want to talk to you. What? It's like, that's nowhere near narrow enough. My God, that's just too big. Now, this is going to get funky. Stay with me now. If they want their error to be 4%, how many more people would we need to survey to make that happen? Do you guys understand that if I make this number here bigger, then this number is going to get smaller? Is that everybody gets that, right? If I divide by a bigger number, it's going to get smaller. I want that number to become 0.04. I want it to be 4%. So now you ready? Watch this. So I'm going to set up my equation, 2 square root. I know P hat is 0.32. I know Q hat is 0.68. But now I'm going to say I don't know what N is. I'm trying to figure out what N needs to be in order to make this 0.04. I know if I make it 0.112, N is 70. But what if I make it 0.04? What would N be? I know it's going to be bigger than 70. And now we got this completely beautiful equation to solve. I don't know if anybody out there agrees with me. That's a beautiful little equation. Stay with me now. Let me do something first. You guys agree with me? One thing I could do right off the bat is divide by 2. Both sides. Bam. So then I get this. I still didn't give myself enough room, did I? All right, let me stop for a minute. I don't know if you guys are with me or not. I really want you to get this. If N is 70, it makes the error 11.2%. So now I'm saying, don't let N be something yet, but make this 4%. We can solve for n. We can see how big of a sample we will need in order to make this the error that small, because that error is too damn high, right? The margin of error is too damn high. That's too old of a meme for you. Okay. So how the hell do I solve this equation? How do I solve that equation? I don't know. Not only is this a fraction, what else is really bad about this side? It's inside of a square root. How the hell do you kill a square root? What's the opposite of a square root?
Square.
Yeah. Let me rewrite this somewhere. I need some more room. Shoot. Well, I'm going to try to keep going. So let's see. If I square both sides. Right. If I square both sides, that kills the square root. So now this is freed up. This is no longer inside the square root. And on this side, 0.02 squared will be 0.0004. You can double check me on that. Oh man, you guys are loving this. All right, so I'm right here. Let me pull this over here so I got some more room. Where am I going to put it? Yeah, let's put it over there. So I got 0.32 times 0.68 divided by n equals 0.0004. All right, I don't know if you guys are still with me. I know we just got really mathish out of nowhere. I want to show you something really cool. I've talked about this before. I could just make these switch places. I can multiply by n and I can divide by 0.04. These guys will switch places. So I get 0.32 times 0.68 divided by 0.0004. Now stay with me. I'm going to show you a shortcut to this in a minute. And I know you guys are out there saying, why the shit didn't you show us the shortcut before we started doing this? Too damn bad. Just hang on. So now if I throw this in the calculator, I will get how big of a sample I need. 70 is not enough. Well, how much do I need to make it 4%? I'm going to figure that out right now. If you throw this in the calculator, I got too many lines over there. The number of lines around this problem is too damn high. There we go. Right, if I throw this in the old calculator, 0.32 times 0.68 divided by that. Let's see if I can do that in my head. Why do you want to do everything in your head, Jeff? Stop it. Oh man, what is that? 800. What's 68% of 800? I don't know. It's 34% of 400. It's 17% of 200. 17% of 200. Is that right, Jeff? That doesn't feel right. Maybe it is right. That can't be right. Wait a minute. All right, Jeff, stop trying to do it in your head, dude. Yeah, I was way off. All right. What do you guys, anybody get something?
544.
All right, that was a long ways to go. I know, but does it make, I really want this to make sense. If n is 70, I get this error. So if I know what I want the error to be, I should be able to figure out what n would make that happen. And this is how I can algebraically do it. So only 70 gives me an error of 11.2. If I take 544 sample size, I can get my error down to 4%. Then I would feel better telling people this. They wouldn't look at me like, what the shit, you really don't know anything. I go, well, I know something. Yeah. All right. So let me see if the book doesn't do it, I'm going to do it for you. I'm going to show you the shortcut to this. I'm going to clear this page. Has everybody got what they want from this? This is a bit of a mess, and I'm sorry. All right, I'm going to clear this away. Here it goes. Bye. Let's see what they do. Let's see if they're as nice to you as I want to be. No, get out of here. Oh, they actually step you through all the steps I just did. Okay, that's fine. Blah, 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 blah. I have no idea if they actually do it. Let me see. Barf. All right, so let me show you this. Here we go. You ready? I'm going to give you the shortcut for if they ask you, if we want our error to be 2%, how many people or something would we survey? So you want equation solve for n. So remember this, the error is 2 times the square root of p hat q hat over n, right? Stay with me now. Here we go. If I divide by 2, I get this. And then if I square both sides, I get, oh shit, in half. I get this. Let's go ahead and do cross multiplication. We haven't done that in a while, right? I can cross multiply. And then I can divide by e squared. So now I get a formula. Sample size must be 4 times p hat q hat over the error squared. So that is a beautiful little equation for if they ask you, I want my error to be something, how big of a sample do I need? You can just plug in everything you know and you'll figure out what the sample size is. Okay, that's freakadelic. Do you need all this? No. This is the derivation of the equation. It's nice if you kind of followed that a bit, but that's the equation itself. All right. They got very mathish today, but you know, it's a math freaking class, so I don't feel too bad about that. All right, I'm going to clear this away. Here it goes. It's going away. It's gone. It's going. It's going. Here it goes. All right. So let's do, let's do this one. Let's do this real quick with our new little formula. So I'll put the formula up here again. So look at number 3. Preliminary results show that 11% lack of health insurance. How many more people do we need to survey to have an error of 2%? So what would E? What's E? What's E?
2%.
Yeah, but how do you write it? Be careful.
Oh, plus or minus
No.
0.02. Sorry.
Yes. You always write a percentage as the number it represents. So 2% is not a number. 0.02 is the number that represents. The math normally doesn't like percentage numbers. It wants the decimal number. Yeah. And then what's p hat? Same idea here. What's p hat?
0.11.
Yep. And then q hat would be 89%. Right? Is everybody with me? If one is 11%, the other one's got to be 89%. And that's all I need. That's all I need. It's just a little more time. All right. So I just put in p hat, q hat over error squared. That's exactly what the formula wants me to do. And now I can figure out how big my sample has to be. 4 over 100 divided by 4 over, oh, come on, Jeff, you can do it. 10,000, 4's cancel, 10,000 divided by 100. Is that just 100? I don't know if I'm doing that right in my head. Roughly. Damn, it was 1,000. I was off by a freaking. So I get, you guys get the answer? 900 and
79.
yes. So that's how big of a sample you would have to take in order to be within just 2%. Holy shit, what did I just do? There we go. Crazy sauce. All right, I'm going to clear this away. It's going away. Bye. All right, so your homework, I know you're kind of freaked out about it, I bet. Not going to be too evil, right? Just got to pay attention if they tell you what p hat is. No reason to try to calculate it. Okay. Oh, no. Oh, they get really nifty. Oh, boy. I forgot they do that. This is neat. They give you this formula. I'm going to let you try to use that sucker. You got to get in that homework and try it out. All right. And then a quick peek ahead. We're going to talk about jetpacks. I love it. All right. Somehow we're going to talk about jetpacks next. All right. I think that's enough for today. I think we've done quite a bit. So let me know if anybody needs to stay after. I also have my office hours today, 2 to 3. If you want to come to those, let me know, or just come. Anybody have questions right now? Oof. All right, I'm going to head out if nobody has questions. I'll see you guys